Alexa, stop. Right, good morning everyone, welcome to another lockdown lesson. Quite a few people asking after this to do with circles. You might have done this before, you might have not done this before. We're going to look at some problems to do with it. I'm really going to show you a bit about where they came from, where the history of people working with circles came from as well. So we've got quite a lot to get through. So we'll start with a bit of a warm-up as always. 6 questions there, some fairly tricky ones to have a go at. So can you work at the answer of those? All of this without a calculator, please. You will need a calculator for the main part of the lesson, but all of this stuff without a calculator, please. Okay, so you've got 6 questions to answer that. As always, let me know in the chat if you're here and if you need any help as well. Good morning, Oliver, as well. Not sure what's happening with your schools as well. Some people are going back, some people are not. I will definitely be here till the end of this term anyway, doing these regular lessons. Number 1, my big rule for number 1 is if you're ever doing 4.7 times 30, don't times a decimal. Do 47 times 30 first. Do 47 times 30, then adjust it for the decimal point there. You might have a slightly quicker way to do that one by kind of cancelling that and that out, but that will always work. If you just get rid of the decimal, work out that one, and then afterwards you can work out what 4.7 times 30 is by just using a bit of place value. And if you did work out this in an exam anyway, you would always get a mark for doing that. So this would be like a 2-mark question, maybe even a 3-mark, probably a 2-mark question. You would get 1 mark if you just worked out that, and then 1 mark for working out that as well. So it's worth doing that because it's easier and it's getting you towards the answer. He's got a fishing report to do. Right there, you know. I've talked to him for the horse today.
Mother, have you got your my sheet too? Oh, it's on top of the fridge. The big one.
Yeah, if you just join us, we're just having those 6 questions that we're going to be looking all about circles today. Some different ways of thinking about them, some tough problems to look at as well. But it's one of those topics that I think you need to just be doing a little bit earlier than you do, because people get really confused with circles, and they are really, really important as well. And we're going to do a bit of a kind of a, not a homework question, but just something, one of the most useful ways that I see in using circles, which I'll post on the page afterwards to see if you've learned what we're going through. Remember this lot without a calculator as well, please. So I said we'll be continuing all the way to the end of the term. In the last week we're doing something a bit different. We're going to try and do a big quiz for all ages, just for one thing that in the last week to do with the maths. We've done other questions as well, and then we're going to have a bit of a kind of an awards night at the end as well, because some of you have been working so hard, well all of you have, and I want to recognise that and give out some prizes and stuff. So that'll be the last week of the term. Right, let's have a look at these because I really want to get on with the other content of the lesson. So first question, 4.7 times 30. So I've taken out the decimal point already and I'm going to do 47 times 30. You might not feel you need to do this, which is fine, but this always works. So 40 times 30, I'm using a grid method. 40 times 30, 4 times 3 is 12. Then we're going to times by 10 twice for the 2 zeros. 7 times 30 is 210. Add those together, that gives me 4,400 and 1,410. Okay, so this is 1,410. So by looking at this now, I can say, well, I'm going to divide this by 10, so it's going to be 141. So question 1, 141. Question 2, let's see if you were listening last lesson. So we got 7x, if I just square that off there, and minus 3x, so that's going to give me 4x. Then we've got negative 2y, and plus 5y is going to give me positive 3y. Question 3, 2 to the power 4 is 2 times 2 times 2 times 2. Don't then write down 8. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 equals 16. I've seen that as a GCSE question so many times, 2 to the power 4. Question 4, the area of the trapezium, tough shape. Now you've got two options here. There was a long formula to remember, or you think about it a bit logically. If I did 12 times 6, that would give me a rectangle that is too big. If I did 8 times 6, that would give me a rectangle that is too small. So I go halfway between 12 and 8, which is 10, and then times that by 6. I'm always taking the mean average of them, the average or the median of the two. So I'm doing 10 times 6, which equals 60 centimetres squared. There is another formula as well, but people struggle to remember this, which is a half A plus B times H. There's that formula you can use as well. It is up to you. It's the same thing really. This I just find a bit easier to remember. Right, rounding to the 1 decimal place. So 1 decimal place is there, so your rounding line goes there. So the 4 is the cut-off point. The 6 is more than 5, well 5 or more, so we round the 4 up. So 5 goes to 28.5. And finally question 6. You add them all together for the mean. If you add those numbers carefully together, you end up with 30. Then divide by how many numbers there are, which is 5, which gives you an average of 6, as in the mean average. Okay, so quite a range of questions there. Some tricky ones if you ask me. This is the other way to do this shape. A lot of people say you must remember this. You can split it into triangles and a rectangle. So it's not essential, but it's a useful one to know to speed things up. Particularly as a lot of you, I'm sure, looking at the higher GCSE paper, learn that formula. Okay, right. So on to circles. So we're going to start. Hopefully some of you got the printout. If you haven't got the printout, don't worry at all. I want you to see, do you know the names of these different parts of a circle? So I've drawn a diagram here. I've put all the ones you would possibly need for GCSE. The order is actually quite important. These are ranked from A being the most important one you need to know, B the next important, C the next important, and so on. So as you get further down the list, there's not a great deal of use for knowing these names, apart from in a question like this in your GCSE. Okay, so can you name as many of those as you know? You can either use a sheet if you print it out, or you can just write down A equals B equals C equals. You can post them on the chat if you want, it's up to you. So do you know your circle parts? Okay, and as I said, please start with A because that's by far the most important, and so is B, and so on and so on. Well done, 6 out of 6 there, brilliant. Well done, Sam, 6 out of 6 there. Oliver, 5 out of 6. Well, there were some tough questions to start with. Okay, so do we know our circle parts? I will be very impressed if you know these without any help at all. I've got to say, when I did GCSE, when I was at school, there's no way I knew all of these names. No way. I only know now because I've started learning to be a teacher. Well, I've been a teacher for a while, to be fair. Don't worry too much about the spelling either, but try your best. But they're never that strict on spelling. As long as it sounds like the right word in maths, you will always get the right mark for it. Yeah, okay. I can't wait for you to teach you about this. And we'll see at the end. We'll teach you more about how to fish. Okay, it's great. It's really important. So, saying the ones you do know. Okay, it's so important to think about the things you definitely do know when you're learning, because you can almost put those to the side and say, I know those. These are the ones I'm not sure about. Okay, well, let's go through some of these because I'm sure some of these you've never heard of before. So, A, first of all, this is a line going all the way across the centre of the circle. It's called the diameter. Okay, so the diameter is the green line going all the way across the circle. I'll put them all on the board in a bit. The red line, which is from the outside to the centre, so it's halfway across, this is called the radius of the circle. And you should notice it's half of the diameter. That's a really important relationship to know. The radius is half of the diameter. Okay, two really important circle words. Everyone needs to know those, whatever level of maths you want to get to. Right, C is the distance around the outside. Now, I guess you could have two words for this. The normal word is the perimeter, because that's the distance around the outside of any shape. However, on a circle, annoyingly, and I don't know why, it has its own special word, which is the circumference, beginning with a C. Circumference is all the way around the outside. It's the perimeter. I don't know why they have an extra word for it, just to annoy us and give us an extra thing to learn. D is the same for any shape. The space inside is the area. That's the same for any shape at all, inside a 2D shape. And then we go on to the real tricky circle words. Okay, next one on the list is a tangent. Now you use this to solve quite a few angle problems if you're taking the higher paper. On the foundation paper, all you need to know is it's a tangent. And it's a straight line that just touches a circle. So it could be over there, it could be over there, it could be anywhere. And they're important in a lot of advanced maths for solving certain problems. So a tangent is a line that just touches a circle. Then we've got these two here, which are quite easy to get mixed up. I always look at G first, and I think of like a Terry's chocolate orange. You know those chocolate oranges? It looks like a piece of chocolate orange. And you call that a segment of orange, don't you? So this is a segment of orange. And this piece here is like a piece of pizza, and that is a sector. So a sector is like a piece of pizza. By all means, next time you have a pizza, just say, can you pass me a sector of pizza? I'm sure that'll make you remember it. You look a bit stupid, but it will make you remember what that is. And that's a segment of orange. So I'll just show those quickly for you. Those are all the different spellings of them there. Remember, A, B, and C, and D are the most important. Those are the ones we'll be working with today. A, B, C, and D. Diameter and radius. Really important ones there. Okay, so we're going to go on to what I call a pint glass challenge here. So I've got a pint glass here. Okay, and I want to know the height of the pint glass. It's quite a big glass, it's quite a tall glass, compared to the distance round the outside, the circumference of the top. I want to know, in centimetres, how much longer do you think the height is than the circumference? So how much longer is the height from there to there than the circumference round the outside in centimetres? Remember, a centimetre is about the width of your little finger. That's about a centimetre there, from there to there. So how many centimetres taller is the height than the distance round the rim there, the circumference of the top on a pint glass? So post your answers in the chat. Let's see who can get the closest to that. There you go, people say minor segment for that one as well. The minor segment is the smallest segment when you mark the segment up. Okay, so how much taller is a pint glass than the circumference around the rim? Double, okay, nice. 1 centimetre longer, 4 to 6 centimetres. Some great estimations here. It's hard to estimate. All pint glasses are slightly different as well. The same, okay, nice. Okay, well, let's measure and see. Okay, so I've measured this piece of string, and this piece of string fits perfectly round the outside. I don't know if you can see that, but this is right round the outside of the rim there. So I've measured that right round. So I'm going to unravel this to see how long the top is. So the top, look at that. The top is actually not far off being twice as big as the height. That is deceiving if you ask me. I mean, look at that difference there. That is the top there. So this distance around the outside, which looks much smaller than the height, is actually way bigger. Okay? I mean, look at that. That's incredible. You would never ever think that by looking at it. Okay? So there's a massive, massive difference there, but it's the wrong way around. Looking at that, it's almost like an optical illusion. You think that is way taller than the distance around the outside. So they're very deceiving circles in how long they really are around the outside, which is actually what makes them work as wheels and things like that, because it means you travel quite a long way for just one rotation. Okay, so quite a big difference there. So this has kind of fascinated people for a long time, the circle, and we go all the way back to Egyptian times. This is the Rind Papyrus in 1650 BC. So 1650 BC, we are talking about well over 3,500 years ago. There is proof on this, I don't quite understand it, but there is proof that the Egyptians worked out how to find the outside of a circle, the circumference of a circle. And what they said was, if you have a circle, they said, if you have a circle like this, they said, took the diameter, and they said the outside was about 3 times bigger than the inside, about 3 times longer than the inside of the circle. They got it a lot more accurate than that, to be fair to them. So they said the circumference is about 3 times longer than this. So if this was 5 centimetres, the outside would be 15 centimetres. It was a bit more than 3, they worked out as. And they started to get more and more accurate. They said, you know what, it's about 3 1/10, about 3.1 times bigger. You know, it's a bit longer than that, it's about 3.14. And they got as accurate as they could with their numbers for calculating these circles. And remember, the Egyptians built the pyramids, so they were very, very good at maths and everything they used there. And then, so, if this example here, so if this was 6 centimetres, the outside of the circle, the circumference will be 6 times 3, would be 18 centimetres, approximately, a bit more than that. Okay, so then, this very famous person called Archimedes, still years and years and years ago, he realised we could get more accurate than this. And he came up with pi, which is 3.142, approximately. So that's how many times bigger the outside is than the inside, 3.142. And we're going to be using that today as our value of pi. This number pi actually goes on forever and ever and ever and ever and ever. It keeps getting more and more accurate as far as it goes. People have calculated to thousands of decimal places. We're going to use about 3.142. So as an example, if we had to find the circumference of this circle, we've got our diameter, we would just do 8 times 3.142. That's all we would need to type in. So we would type in here 8 times 3.142. You can use your pi button if you've got a scientific calculator. By all means, you can type that in instead, because pi is a Greek letter that Archimedes named this thing after. So if I did 3.142 times 8, that's going to give me an answer of 25.136. We're going to leave all of our answers to one decimal place, so that is going to be 25.1 centimetres. So that's an example there for how to find the circumference of a circle. It's not a bad formula if you're happy using pi. Okay, so can we have a go at those 6 questions there? I'm sure you'll whiz through these. Let's find the circumference of each one. Leave your answer to one decimal place, please. Okay, so you're finding the circumference of each one. Remember, the formula is the diameter times by pi. The diameter times by 3.14, which is shown there. This is the Greek symbol for pi. And please use a calculator for this. Please don't start trying to work those out in your head. Check your rounding as well. The first answer is not 12.5. You are very close, but check your rounding. Let's have a look at the first one, because it's one of those common rounding errors. So you've done 4. So question 1, you should have done 4 times 3.142, or 4 times pi, which gives you 12.568. Don't then just get excited and just write down 12.5. There's your rounding line. So this is going to equal 12.6 centimetres. Put your units in as well. It is a length. Okay, it is a piece of string. It is a piece of string that goes round the circle. So make sure we put our units in. Okay, just another 30 seconds on this. You'll see it's very similar. It's just as you know the formulas, circles are not things to be scared of. They're actually probably the easier ones to work out, because it's very easy to know what you are timesing. Just one length times by this magic number called pi. Okay, right, let's check your answers. So you should have 12.6 centimetres, 22 centimetres, or 22.0 is fine, 14.1, 37.7, 18.9 and 31.4 centimetres. Okay, so that is finding the circumference of a circle. Now, that in itself I think is quite easy. It gets confusing when we look at the area as well, because the formulas then start to get mixed up. We've got one nice formula there. The outside is pi times bigger than the diameter. Watch out for those ones. Remember, I've only given you the radius there. So the diameter is 6. So make sure you know when you start with, haven't been given the diameter or the radius, and make sure you double it or sometimes halve it depending on what you're doing. Okay, so the area. How do you find the area of the square? Can you write down post on the chat, please, the area of that square. You should hopefully know to find the area of a shape like that. If not, please try the GCSE area lesson, an important lesson I did quite a few weeks ago now. Okay, if you did get 4 out of 6 on that, was it the last 2 you got wrong by not doubling that radius? Make sure you know the mistake you made. Okay, so you would do 3 times 3 to get 9 centimetres squared for this. You times the base by the height, 3 times 3. So imagine 4 of these squares now together. So they're all 9, so we've got 9, 9, 9 and 9. In total, this square is going to be 36 centimetres squared. Okay? So I'm now going to put a circle around this. I'll put a circle around there. I'll put a circle. So is the area of the circle bigger or smaller than the 4 squares? Okay? Is it bigger or smaller than the 4 squares? Okay, good. It's smaller, isn't it? This is smaller than the squares. We know that. So you'll notice this circle here, okay, it's made up of these squares. The radius of this circle is 3. So one of these squares is 3 times 3. Another square is 3 times 3, 3 times 3 and 3 times 3. So we can do one of these squares, which is 9, and times it by 4, but that's a bit too big. In fact, it's less than 4 of the squares. If you actually work this out, it is exactly 3.142 blah 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 blah. It's pi numbers of squares. So to work out the area of a circle, you work out the area of one square and then times it by pi. One square times it by pi. Okay? So to kind of simplify that a bit, if we got one square here, to find one square, we do 9 times 9. And then we times it by pi. So if you've got your square, if you've got your circle here, which is 9 centimetres, we would do 9 times 9 to find one square, and then we times that by pi, by 3.142. And that would be the area of that circle. So to find one square, you are doing 9 times 9 and then timesing it by 3.142. Or as a formula, radius times pi is the area of a circle. So for this one, I'll be doing 9 times 9 . 9 times 9 times 3.142, which gives me an area, so it's measured in square centimetres, not in centimetres. Okay, hopefully that makes sense. Let's have a go at 6 questions again, please. So can you find the area of each one? Remember, you need the radius this time, not the diameter. You are using the radius. Brilliant, well followed everyone on that, fantastic work. Got the answer right, so have a go at these 6 questions, then we will look at some much tougher problem solving questions. I'm going to put 2 extension questions on the board as well. Hold on, Theo. Okay, so there's two tougher questions on the board there, a semicircle and a sector to have a look at. So see how you get on with those. Okay?
Yep, finished.
Oh, wow. Okay, good. Yeah, fantastic. Right, there's one more thing. Just on that, we'll just say what you want to do next time you go just to the next one, okay? The next time, maybe a certain fish you want to catch, maybe you want to take your daddy along, something like that. Really good. Really, and if you can colour those in as well, then yeah, fantastic. That's lovely, isn't it? And then we'll show it, and then we'll check actual spelling steps and we can show it to go. Okay, we all getting on okay? The first one, I'll just show the first one just to make sure so you can check your work. So you should be doing for question 1, you should be doing 4 times 4 times pi. Which is 50.3 centimetres squared. So that is question 1 there. There is a pi button on your calculator. You can press the pi button instead of typing in 3.142 all the time. You need to give your answer with a decimal though in these questions. It just depends how confident you are with your calculator or not. Right, so someone's laptop, first I'll just go through this one again. So to find the area, you do the radius times the radius, so 4 times 4, and then times it by your magic circle number, by pi. So it's radius times pi. Okay, I think it's a really nice formula. The issue is it's very similar to the one for the circumference. If you get it mixed up and use the wrong one, you get the complete wrong answer on all occasions except for one. Right, somebody said there was an issue with the laptops freezing and stuff. Is it all okay now? Careful with these last two as well. Don't just go into kind of autopilot and just keep doing the same thing. Always check the question carefully to start with. And then you've got those two really tough ones on the board there, which I'll try and keep my head out of the way of. If you've done them all, please let me know what you've got for questions 7 and 8. What about your packed lunch, Theo? Surely that's going to go on your equipment.
Oh,
And then you're done, do all your lunch and then we're done. Very important. Keep your
Don't
lunch
read
here.
it yet.
I won't, I'll read it at the end.
Yeah.
Okay, right, let's go through these. I'll look at these ones. These are really advanced, these ones. These are the ones that you're doing, particularly if you've never done circles before, these are the ones to look for. But you should understand these when I go through them, because it's a nice way to look at them. So first questions on the board, there your answers are. So you're just putting the same formula in. Remember on this one, you are not doing 4 times 4 times pi, you're doing 2 times 2 times pi, because you use the radius. Okay? And same for this, when you're doing 4.5 times 4.5 times pi, not 9 times 9 times pi. Make sure you know whether you've got the radius or the diameter. Right, so on to these tough ones here. Now, these are all sectors of circles. These are fractions of circles. So this is half a circle. So when you get these questions, imagine you've got the whole circle first. So if you have the whole circle going all the way around like this, to find the area of this, you would do, the radius is 7, you would do 7 times pi, which gives you 153.958. So that is the whole circle. But this is half a circle. So surely if this is a full circle, I am going to divide that by 2, which gives me my answer of 77 centimetres squared. Okay, so you find the whole circle first and then you divide it to get your fraction of the circle. So this one here, again, imagine you've got the whole circle, which is one big circle. The radius is 10, so the whole circle is 10 times 10 times pi, which is going to give you 314.2. Now you need to think carefully. How much of a circle is this? Is it half a circle? Is it a quarter of a circle? How can you work it out? Well, you know that there's 360 degrees in a full circle. So in a full circle, it's 360 degrees going all the way around. This is 60. So how many 60s go into 360? And you should work out it's 6. So this is a sixth of a whole circle. So you can then do 314.2 divided by 6 to give you 52.4 centimetres squared. Okay, so if we can work out the full circle, we can work out your fractions of circles. But please don't worry too much about that. This is where we're at for now, particularly if you've not done this before. Okay, we are just going to finish with a few problems to do with this now. So when you get worded questions on circles, which in the new GCSE, most of them are worded problems and they can be quite tricky. They're all to do with finding the circumference or the area. So the first thing you need to think about the question is, do I need to find the area or the circumference? That's the first thing you should be thinking about. And then I would work those out. So if you think this is all to do with the area, you're going to find the area. If you think it's all to do with the circumference, the outside, find the circumference. Then do this, make sure you use the right formula, and then after you've worked it out, read the question again and answer it. So use the answer you've got. So remember, the area is all about filling something up with it. So if you've got a space and you want to fill it with something, if you want to fill it with, just fill it with, I don't know, grass or paint or wallpaper, you're looking at the area. The outside is all about the perimeter, the circumference. So if you're looking at the outside, for example, the amount of ribbon going around the outside of a cake, a circular cake, maybe the fence going around the outside of a field, how many times something spins round, it's the outside you're interested in. That is the circumference. So work out which you need to find and find it. Okay, and then answer the question. So let's have a look at this first question. So it's about a bike. So here's a bike there. The diameter of the wheels on this bike are 52 centimetres. So the diameter from there to there is 52 centimetres. How far will the bike travel along the ground if the wheels rotate round one full turn? Okay? So when a wheel spins round once, that's how far it's travelled. So think about, what is this to do with the outside of the wheel or the area of the wheel? Okay, so try and calculate something for part A now. I wanted to do this problem because this is one that confuses people a lot. Sorry, Dan, I'm not sure what's going on with the computer there. I think everyone else is fine with the stream at the moment. Okay, so whenever you're talking about a wheel spinning round, this is a really good tip for you, it's always the circumference you find. Because the circumference, if you imagine one of those meter wheels, those trundle wheels that you go around with, every time it spins around one, it clicks, doesn't it? It clicks, clicks, clicks. If you use one of those wheels, it clicks, and that's a meter. And it's the outside of the wheel that counts. So to start with on this one, you are looking at your bike wheel, which you know is 52 centimetres. So you're going to find the diameter of that, which is 52, and you then find the circumference. So 52 times pi gives me 163.4. I'm going to leave 38 in for now. So that's how far it goes with one turn. So the answer is 163.38 centimetres, or you could say 1.63 metres. So every time the wheel spins round once, the bike goes 1.63 metres. Then it says, how far will the bike travel if the wheels turn around 200 times? So you are going to have to times that by 200, aren't you? We're going to have to times that by 200, which gives us 326.77 metres. Okay? So when you're travelling on a bike, if you go 326 metres, which is quite a long way, your bike wheels have turned round 200 times. And that's how a bike works. Every time it turns round, you travel. So the more circular there are, the better. Almost goes back to this glass here, because it's surprising how one turn of that, how long it actually is, which is one of the reasons you want your wheels to be circular, because you get a lot more distance for one rotation round. Okay, so that was a circumference question there. Okay, brilliant, great work there. I will put your answer in metres. It will probably say in metres in the exam, but we want metres rather than centimetres, so a big distance. Okay, next problem. Okay, a school is decorating a disco hall by painting 75 large silver discs with a radius of 0.6 metres. So they are painting these discs silver, sticking them on the walls to decorate the place. One pot of paint is enough to paint 20 metres squared. How many pots of paint do they need to buy? Okay, so see if you can work on that one. How many pots of paint do they need to buy to paint all 75 silver discs? Okay, right, we're going to have a look at this problem then, and then we're going to finish with something which is going to change your lives. Okay, so if we're talking about painting something, we are definitely talking about the area. So you want to find the area of one of these discs. So just ignore that. So one of those discs, the area, is going to be 0.6 times 0.6 times 3.142. Okay, so 0.6 times 0.6 times 3.142. Gives me 1.13. 1.13 square metres. Okay, now I have 75 of those. So it's going to be 75 times 1.13, which gives me 84.8 square metres I need. Now it says here, one pot of paint is enough to paint 20 square metres. So I've got this in total, so I'm going to need 4 pots of paint. If there's 20 in each one, that would give me 80 metres. Annoyingly, I'm going to have to buy another pot of paint because I'm not quite good enough. So I'm going to need 5 pots of paint. Okay, so that is very practical maths. If you were doing this, you would not want to keep buying paint or buy too much paint. You need to work out how much paint you need. So you work out the area of the discs and then paint them. Okay? Right, we're just going to finish with one more problem. This, for me, is a massive problem, and it's all to do with ordering pizza. Okay? Brilliant work, people. They've got 5 for that as well. So, this is Domino's pizza. You have your small pizzas, which is enough for one, or supposedly enough for one, which are 9.5 inches across, or 4.75 inches for a radius, because they measure the diameter of the pizzas. You've got a large pizza there, okay, which is 6.5 centimetres, well, inches, this is not centimetres, 6.75 inches across, or 13.5 inches all the way across. So, what I want to know is, if you're ordering pizza with a friend or with your brother or sister or something, you might say, let's get 1 pizza each, which is actually more expensive than getting 1 large one. But why do you want to get 1 pizza each? Probably because you're thinking, I want my own pizza, I also want to get more, there's not enough there. I want to get as much pizza as I can possibly get. So, how much more pizza do you get if you get 2 small pizzas compared with a large pizza? Put your answers on the chat. How much more do you get if you get 2 of these? So if you get 2 9.5 inch pizzas, how much more pizza do you get than 1 large pizza? So these are your small pizzas, these are your large pizzas. How much extra pizza do you get from getting this deal there with the 2 small ones? How much extra pizza do you get? So 2 9.5 inch pizzas or 1 13.5 inch pizzas. Okay, love how we are working out. 5 inches more in 2 different flavours, 5.5 inches. Okay, so you're getting more pizza there. Okay, so what a lot of people do is they say, well, 13.5 inches and 2 of those is 19 inches. So you get more if you get this one, don't you? But it's not that. You don't just eat across here, you eat the area of the pizza. So the only way to work it out would be to work out the area of each pizza. So I'm going to work out the area of that pizza there. So I'm going to use my area formula. So it's 4.75 times 4.75 times pi for that one. So 4.75 times 4.75 times pi. Then times it by 2. Gives me 100. So for both pizzas, about 70 each. For both of these pizzas together, I'm getting 142 inches of pizza. Okay, so that's how much pizza you get for those 2 small ones. Now for the large one, I only get 1 of those, so I'm doing 6.75 times 6.75 times pi. Gives me 143 inches squared. So I actually get more pizza in 1 large one than I do in 2 small ones. And this costs almost twice as expensive as that one. That is so much more money than this one here. So always buy the large pizza and share it. You can go half and half for free as well. So if you don't like pineapple, if you're one of those people that say you can't put pineapple on a pizza, don't put pineapple on your half. Let the other person put pineapple on their half and just deal with the fact they like pineapple. But always get the large pizza. It's worth way more than it thinks. And Domino's Pizza, all pizza shops know this, and they love selling you small pizzas because they're ripping you off. Get the big pizza and split it. You get so much more and it's so much cheaper. Okay? This costs about, I think this costs about £18. These cost about £13 each. So you're getting the same amount of pizza, you're actually getting slightly more for paying £18 rather than paying £26. So Circle shows you that. So always get the big pizza. Okay? It will save you so much money in your life. Think how many pizzas you're going to buy in your entire lifetime when you become an adult and when you're a parent, when you start buying pizzas for your kids. Always buy the smalls. Always buy the big ones. And stop asking your parents for a small pizza saying you want more. You don't even get more. Get the big pizzas. Okay? Right, so hopefully you've seen that circles are nice and important. They are really, really big things. They're in lots of things in real life. There's some exam questions that I'll put out for you. If you want to send me those, I will have a look at those and mark them for you. But great work today, and we'll be back next week. Thank you very much. That pizza thing, please. Keep buying your large pizzas. So important. Yes, £2 pizzas from Iceland are even cheaper, but always buy the big ones. Wherever you are, the biggest. Pineapple's fine on a pizza as well. I am a pineapple pro person. Okay, see you later everyone. I could talk for ages about pizza and it is making me hungry too.